Some weapons change the course of battles, others change the course of history, but a new generation of weapons may change the entire world. They travel faster than sound, faster than bullets, faster than most defense systems can react. These are hypersonic missiles, machines so powerful that they can cross entire countries within minutes at incredible speeds. The air itself begins to burn, temperatures rise dramatically, shock waves form around the missile, and intercepting it becomes almost impossible. Unlike traditional missiles, these weapons do not simply fly, they maneuver, they change direction, they confuse radar systems, and they leave very little time for anyone to respond. Today, several nations are racing to develop more advanced versions because whoever controls this technology may control the future of warfare. But how do these extraordinary machines work? How can something move so quickly and still remain under control? And could these weapons change the balance of power forever? Tonight, we will discover the extraordinary science behind hypersonic missiles. Before we can understand hypersonic missiles, we must first understand speed. Sound travels through the atmosphere at approximately 1,200 kilometers per hour. This speed is known as Mach 1. When an aircraft exceeds that speed, it breaks the sound barrier. Powerful shock waves appear, and an enormous amount of energy is released into the surrounding air. As technology advanced, engineers developed aircraft capable of reaching Mach 2, then Mach 3, then even greater speeds. But hypersonic technology exists in an entirely different category. These extraordinary weapons travel at Mach 5 or even faster. That means they can move at more than 6,000 kilometers per hour. Some advanced systems may eventually travel at astonishing speeds, approaching Mach 10. At such incredible velocities, the atmosphere itself becomes an enemy. Friction generates enormous heat. Temperatures rise dramatically. The outer surface must survive conditions similar to those experienced by spacecraft returning to Earth. Every component must be designed to withstand extraordinary pressure. Every calculation must be absolutely precise, because even the smallest error could destroy the missile completely. Yet despite these challenges, engineers continue pushing the boundaries of modern technology, because achieving incredible speed is only the first challenge. The next challenge is maintaining complete control. Moving at hypersonic speed is very different from ordinary flight. At these incredible velocities, air behaves in unusual ways. The atmosphere becomes compressed. Temperatures increase rapidly. Powerful shock waves form around the missile. Every surface experiences enormous stress. Even tiny imperfections can become extremely dangerous. To survive, engineers use special materials, heat-resistant metals, advanced carbon composites, and protective coatings designed to withstand extraordinary temperatures. But speed alone is not enough. The missile must also remain stable. Powerful guidance systems continuously calculate its position. Onboard computers analyze enormous amounts of data. Tiny adjustments are made every second. Unlike traditional ballistic missiles, hypersonic weapons can change direction. They can rise, they can descend, and they can suddenly alter their flight path. This ability makes them extremely difficult to predict. Meanwhile, engineers continue improving propulsion systems, because maintaining such incredible speeds requires enormous amounts of energy, and that challenge has led scientists to create some of the most advanced engines ever built. Every extraordinary machine depends upon an extraordinary engine. Hypersonic missiles are no exception. At low speeds, conventional jet engines can perform extremely well, but at hypersonic speeds, everything changes. The air enters the engine at incredible velocity. Temperatures increase dramatically. Pressure rises, and ordinary engines can no longer operate efficiently. To solve this problem, engineers developed a remarkable technology, the scramjet engine. Unlike traditional engines, a scramjet contains very few moving parts. Instead, the tremendous speed of the missile compresses incoming air. Fuel is injected, combustion begins, and enormous amounts of energy are released. The process happens in fractions of a second, yet maintaining stability remains extremely difficult. Tiny changes in temperature can affect performance. Small variations in airflow can create major problems. Every component must function perfectly because failure is not an option. Meanwhile, researchers continue designing more powerful systems. The goal is simple: greater speed, longer range, and increased precision, but extraordinary speed creates another challenge: detection. For decades, modern air defense systems were designed to stop traditional missiles. Radar systems detected incoming threats. Computers analyzed their paths, interceptors were launched, and the target was destroyed. At least that was the plan. Hypersonic missiles changed everything. Their speed alone creates a serious problem. By the time a radar system detects the missile, only a few moments remain. But speed is not the only advantage. Unlike traditional ballistic missiles, hypersonic weapons can constantly change direction. They can climb higher, they can dive lower, and they can suddenly alter their flight path. This makes their movement extremely difficult to predict. Meanwhile, the intense heat surrounding the missile creates another challenge. Sensors struggle to collect accurate information. Tracking systems must process enormous amounts of data in very little time. Military planners around the world understand the danger. Scientists continue developing more advanced defensive systems, powerful satellites, improved radar networks. Artificial intelligence and entirely new technologies are now being tested because the race has already begun, and nobody wants to fall behind. The race has already begun across the world. Scientists, engineers, and military planners are working day and night. Their objective is simple: build faster weapons, develop stronger defenses, and secure a technological advantage. Powerful laboratories continue testing new materials, advanced computers analyze enormous amounts of data. Engineers search for ways to improve speed, range, accuracy, and reliability. Every successful test represents a major achievement. Every failure provides valuable information, because developing hypersonic technology is one of the most difficult engineering challenges ever attempted. Meanwhile, governments invest billions of dollars into research and development. Powerful radar systems are upgraded, satellites become more advanced, artificial intelligence begins playing an increasingly important role. The world understands that this technology could shape the future of warfare, but speed alone will never determine the outcome. Strategy, intelligence, innovation, and preparation will remain equally important. And as this race continues, one final question remains: will hypersonic missiles transform the world forever? So, what makes hypersonic missiles so extraordinary? The answer is simple: speed, precision, and unpredictability. These remarkable machines represent one of the greatest technological achievements of the modern era. They travel at astonishing speeds, they endure extreme temperatures, and they push engineering to its absolute limits. Yet their existence also raises important questions. How will warfare change? How will nations respond? And what technologies will appear next? Throughout history, humanity has always searched for faster machines, stronger materials, and more powerful inventions. Hypersonic technology may be only the beginning, because the future is arriving faster than ever before. If you enjoyed this documentary, don't forget to leave a like, subscribe to RailForge, and join us as we continue exploring space, military technology, engineering, science, and the greatest mysteries of our world. Thank you for watching, and we'll see you in the next documentary.